Hello and welcome back to the Python programming course. How did you go with experimenting after the previous tutorial? Did you have a chance to play around with the joint plot and specify different types of kinds or experiment with the variables? I hope you had a chance to do that and were able to kind of let that knowledge sink in about the joint plot. Today we're going to continue and we're going to look at histograms. So first thing, I'm going to zoom back into the chart or into Jupyter so we can see a bit better. And to make some space, I'm actually going to remove the header and the toolbar. Okay, so let's proceed with today's tutorial. So first thing, I'm going to change this to marker or markup by clicking M and then add a line here. And so today we're talking about histograms. All right, so something that we already know about histograms. So let's say already know this method. By the way, today is going to be a very quick tutorial, so we're just going to refresh on histograms before we proceed further in this section. So M1, we already know this approach to histograms. We know that you can say this plot movies dot audience rating. Let's run that. There you go. So you can see we've just created a histogram very quickly, and it's even got the probability density function. So if I specify bins, I can say I might want less bins. I might say 15 or more bins. So you can specify less or more if you like. Therefore, it will look a bit different, but the essence stays the same. And another one that we can create is, let's just take this and say M2 critic rating. So this is the same thing, but applied to critic rating. So I wanted to show you another way of creating this distribution, and this is through pyplot. Now, Seaborn is kind of like an upgrade on top of pyplot, or is an add-on on top of pyplot in terms of packaging, because it does use the same functions in pyplot. It just packages in a lot of convenient things, like for instance, it adds this probability density function, it adds the grid, it makes the colors look good. So let's have a look at what the same distribution would look like without Seaborn, with just pyplot. We'd say n1 equals plt.hst or hist. Here we'll say movies, audience rating. So if you press tab, then it will autocomplete for you, and bins equals 15. So if I run that, you can see that's what the distribution would have looked like without Seaborn. So if I go up, that's the Seaborn one. That's the pyplot one. As you can see, the Seaborn even changed the x-axis limits from -20 to 120, and that's why it looks a bit smaller or further away. In pyplot, that doesn't happen. And one more thing is, you can actually still see the grid. This grid is created by Seaborn. If not for Seaborn, this chart would have looked quite different. It would have not had the grid. It's just kind of like a styling thing that Seaborn does. So if you want to see the original, then we're going to just do this. We're going to say sns.setStyle, and here we're going to say white. So this is somewhat what the original would look like. It would still look a bit different, but this is more what the pyplot version of that chart looks like. And now we're going to do the same thing for critic rating. And notice that the grid didn't appear here as well. That's because this styling that you set is set for the package or for your instance of this Python that you're running. So from now on, even if you rerun this chart, so if you run that, you'll see that it doesn't have the grid anymore. So if you want to return the grid, you'll have to add a different function here. So I'll say dark grid. So if you run that, you'll see that the grid is back. So maybe write these down. These are quite useful if you want to change the styling. You've got dark grid, you've got white, you've got quite a few options. We're actually running a bit ahead of ourselves. We'll talk about styling further down in this section of the course, but it's a good intro anyway. So why did we create these two charts? What's so special about them? Well, this is an interesting observation, and not just interesting in terms of, because these are indeed quite ordinary visualizations. They don't have anything complicated about them, unlike the ones that we created previously. But what you will find is that they are quite interesting in terms of what they're saying. So here you've got the audience rating, and here you've got the critic rating. So the audience rating, it's funny to see but it is normally, it looks like it's normally distributed. Well, more or less so, it's normally distributed. So you can see that you've got the middle somewhere around maybe 50 or 60 percentages, and then it drops off both ways. Looks like a bell curve, right? So if you look at this shape here, you'll see that it does indeed look like a bell curve. Whereas the critic rating, it is actually not normally distributed. So even though this has the tails on the left and right, if you look at this version over here, you can see that it's more kind of uniformly distributed. So it's got this average line, or the horizontal line going through here. So some of the ratings are above, so some of the ratings come more often, frequently, and those are lower ratings. And but at the same time, more or less, it's uniform here, it's uniform here. So critics, unlike audience, they behave in a different way. So they have certain criteria how they mark the movie, and that's why this behavior isn't normally distributed. So it's got some rules behind it. Whereas when you've got just emotional type of behavior, which is the audience, which is normal human psychology, that is all very often distributed normally. So it's interesting to observe how this data set actually backs that concept, that when something is natural, when your impression about a movie, and then and you just post a rating, and you have thousands and thousands and thousands of people posting their ratings just based on their natural intuition, you get a normal distribution. When critics come into play, when they're using certain criteria to judge movies, when they're looking at lighting, when they're looking at sound effects, when they're looking at the plot, and they have certain rules according to which they judge, then the normal distribution is lost. Personally, I find that very interesting, and this is something that I would definitely recommend conveying to the audience or including in the report. So here I would say chart 2, and here I would say chart 3. So very, very fascinating findings like that. Always interesting to see theories or hypotheses backed by actual data that we work with. So there we go. That's how we create histograms. It's just a quick refresher. And we got 2 more charts. As you can see, that was very quick. We've already gotten 3 charts. And also we saw some very interesting phenomenon, being a phenomenon confirming the normal distribution and the uniform distributions. So hopefully you enjoyed that, and I look forward to seeing you on the next tutorial. Until then, happy coding!